All right, Geometry 2 students, this is kind of back with you again to give you a few more examples. Now, in this example, it says the length of yx is 20 feet. They want us to explain why the length of yz would be the same. Okay? Now, we have this exterior angle here, which is 140 degrees. Now, class, remember, a straight line, let's review, measures 180 degrees. So this, for example, so now I have this angle that's 140 degrees, which is right here, right here. Now, I can find this angle right here. Since the straight line is 180, I'm looking at 180 minus 140. So that would give me 40 degrees for that angle, okay? These are supplementary angles, remember? Two angles add up to 180 degrees, okay? So I'm gonna squeeze in 40 degrees right here. Now, I wanna prove that YZ would be the same as XY, okay? So here I know that angle YXZ equals 40 degrees. And I know that angle YZX is 40 degrees. Those two are 40. Okay. So now I'm looking at the converse of our isosceles triangle theorem. Okay. Looking at the converse. Since these two angles are the same, the opposite sides will be the same. Okay. So this side will be congruent to this side. Okay. So now we know that since these two angles are the same, and we're looking at the converse of the equilateral triangle theorem, the converse. So since these two are the same, therefore, XY will be congruent to YX by the converse of equilateral theorem. Okay? By the converse of I said equilateral, let me go back, because I said that the angles were congruent. So I'm calling that off. So I'm looking at angles, so converse of the isosceles. All right. I'll say that isosceles triangle theorem. Okay. So since these two angles are congruent, the opposite sides will be congruent. Okay. So that's one example I have for you here. Now, let's look at another example. So I made a mistake there and I said equilateral. I meant isosceles, okay? Isosceles class. Now let's look at another example. So I have this triangle. I'm going to call it triangle ABC. Okay. Now I'm going to extend this a little bit. I'm going to call this angle D here and angle E here. Okay. Now angle A is 96 degrees. Okay. And I have these two sides congruent. And I have these two sides congruent. Okay. So let's find the measurement of angle E. Let's find the measurement of angle E. Now in triangle ABC, this vertex angle is 96 degrees. We know that our base angles will be congruent. Okay. So I'm going to call these two here X for right now. Okay. So we have X plus 96 equals 180. 2X plus 96 equals 180. And when we subtract 96 from 180, we get 84. So 2X equals 84. And when we divide 84 by 2, we get what? 42. So we have 42. So now I'm looking at this to be 42 degrees. Okay, class? So we're trying to find angle E. Measure angle E. Now, remember vertical angles? Vertical angles are congruent. That's when we have two straight lines that intersect. So since this is 42 degrees, this will be 42 degrees, okay? Now these two sides are congruent, so the angles opposite will be congruent. All right? So here I'm going to say the measurement of angle D plus the measurement of angle E plus 42 equals 180 degrees, okay? So you have that. And that 42 degrees came from angle CDCE, okay? Matter of fact, let me go back and change that and add that in for you, okay? So the measurement of angle D, C, and E. Okay, remember when you have a vertex that goes to different angles, you have to symbolize it with all three letters, okay? So now we have 42 plus X equals 180. So 42 plus 2X equals 180. And we subtract 42 from 180. Have 138. So 2X equals 138. And when we divide 138 by 2, so now we know X is 69. So the measurement of angle E will be 69 degrees. Okay, 69 degrees. Okay, let's look at two more examples, and then you should be able to complete practice A, reading strategy, word problems, and your quiz. Okay. So let's look at this example. In this example, we have triangle RUS. We have that bisector there. Okay. Right here, class, this is angle S. Okay. Angle S is 57 degrees. Okay. Here we have this angle bisector. At this point, this vertex here is T, okay? So class, we want to find the measurement of angle TRU. All right, TRU. Let me add a few more things in here. Here we have an isosceles triangle. Okay. Now, so here, this side is going to this side. Therefore, this side is mapping to this angle. This side maps to this angle. And remember, since the two sides are congruent, the opposite angles will be congruent. So angle U is 57 degrees. So now we're going to find angle R. We're going to find angle R, okay? So the measurement of angle R plus the measurement of angle U plus the measurement of angle S is 180. So we got the measurement of angle R plus 57 plus 57 equals 180. The measurement of angle R plus what? 114 maybe? Plus 114 equals 180. Okay? Equals 180. Subtract 114 from 180. 66. So we know the measurement angle R is 66 degrees. Now, but here we have an angle bisector. So we know that the measurement of angle SRT plus the measurement of angle TRU is 66 degrees. Okay? 66 degrees. Now they're both congruent. So we have x plus x equals 66. 2x is 66. So x is 33. Therefore, the angle TRU is 33 degrees. And that's it. Okay? That is it. All righty? Okay. Now I'm going to give you one more example, class, and then you can complete your assignments. So we have this triangle. That. Do a little better job here, class. Okay, so let's say we have triangle BCD. And it's equiangular. Okay, it is equiangular. Side BC is 3/2 x plus 2. And side CD is 5/4 x plus 6. Okay? So let's find BC. Let's find the distance of BC. Now remember, since the triangle is equiangular, the sides will be equilateral. So here we have 3/2 x plus 2 to be equal to 5/4 x plus 6. Okay? So one method we can do here is clear the fractions. So let's find our least common denominator. Okay, or least common multiple. Now we have 2 and 4. 2 is the smallest number. 2 goes into itself. 2 goes into 4 as well. 4 goes into itself. Okay, so our LCM, or you can say LCD, we're looking at 4. Multiplying each term by 4, we'll clear the fractions, okay? So we have 4 times 3/2 x plus 4 times 2 plus 4 times 5/4 x plus 4 times 6. 4 times 3 is 12 divided by 2 is 6. So now fraction gone, okay? 4 times 3 is 12 divided by 2 is 6, plus 4 times 2 is 8. 4 times 5 is 20 divided by 4 is 5. So 5x, fraction gone. Plus 4 times 6 is 24. Okay? 24. Now, we have unlike terms on the same side, so we have to go with equal sign. So we subtract 5x. So we have x plus 8 equals 24. Okay. X plus 8 equals 24. Now, when we subtract 8 on both sides, so x plus 8 equals 24. We subtract 8, so x is 13. Okay, so we have 13. X to be 13. Okay, so we have 3x squared, 3/2 x plus 2, 5/4 x plus 6. Okay, so 4, that's 12, 6, 8, 5, 24, subtract 1, subtract that, 24 minus 8, and I made a mistake. That's what I was looking at, class. I was like, hold on. Let me slow down here. So I'm looking at 16, okay? Now, so to find BC, I have 3/2 times x, which is 16 plus 2, okay? Now, 16 times 3 will give us 48, all right? 48 divided by 2 is 24, so that's 24 plus 2, which will give us our 26, okay? It will give us our 26. All righty? And that's it. Now let's look at, I know I didn't ask you to find this, class, but let's find CD. CD should also be 26. I just want to show you a little bit with these fractions. So we have 5/4 times 16 plus 2. 16 times 5 is, mine went blank, 80. Okay, I was thinking 80. 80 divided by 4 is 20. Okay, plus my 6, which will give us 26. Okay, and that is it. All right, class. So thank you all for your time and have a great day.